Hello, math friends and students and associates, and thanks for dropping by. This is Zig's Math Lessons. Let's get started with recursive sequences and formulas. There are two primary ways to define a sequence using a formula. We can use the explicit or general formula, and that's the style we've been using lately in the past two lessons. It's a formula into which you can substitute a number. Like say you wanted the 347th term, you would just sub in 347 for n and do the math and find out what it was. But there's another way to define a formula. We could use the recursive formula, or some say the recursion formula. This will be the subject of this lesson. In this type of formula, each term is defined in terms of that term's neighbors on the left, usually the term or terms that precede the term in the sequence. Both arithmetic and geometric sequences can be defined recursively. For arithmetic, as an example, we could say that t sub n, a given term, is the previous term. Now t sub n minus 1 means the previous term. So a given term is the previous term plus d. Or you could define it recursively by saying the next term is the current term plus d. Same with geometric. We could say each term is the previous term times r. Or we might say the next term is the current term times r. Example. Here's an example of a sequence defined recursively. Find the first 7 terms. Okay, so t sub 1 is 3, t sub 2 is negative 2, and t sub n is 2 times t sub n minus 1 plus t sub n minus 2. Now, it would be really good to look at this and say each term is 2 times the previous term. Anytime you see t sub n minus 1, think the previous term, plus, and if you see t sub n minus 2, it's the one that came before that. So if you could make up a little kind of mantra in your imagination that says each term is 2 times the previous term plus the one that came before that, then you're ready to list these terms. I'd like you to notice that this formula comes in 2 parts. The formula is all of this is the formula. So the first term is defined, and sometimes the second term is also defined, and the reason is because they don't have neighbors on the left. If t sub 1 doesn't have a previous term, so it has to be defined separately. Hence, these formulas come in 2 parts. Let's list them. T sub 1 is 3. That's easy. T sub 2 is minus 2. That's easy. Now t sub 3, well, we've got our little mantra here. It's 2 times the previous term plus the one that came before that. So 2 times the previous term plus the one that came before that, which is 2 times, looking up here, the previous term plus the one that came before that. And that's minus 4 plus 3. Again, t sub 4. 2 times the previous term here, plus the one that came before that, minus 2. 2 times the previous term plus the one that came before that. That's minus 2, subtract 2. T sub 5, again, it will be 2 times the previous term, 2 times the previous term plus the one that came before that. So it'll be 2 times minus 4 plus minus 1, which is minus 8, subtract 1, minus 9. T sub 5, T sub 6, 2 times the previous term, 2 times this guy, plus the one that came before that, this guy, minus 18, subtract 4, minus 22. And finally, T sub 7. 2 times the previous term plus the one that came before that. Minus 2 times minus 22 is minus 44. Subtract 9, minus 53. So if we lay out all the terms in a row and have a look at them, we have the sequence. 3 minus 2 minus 1. But if we look over here, it's 3 minus 2 minus 1 minus 4 minus 9 minus 22 minus 53. It takes on a random appearance when sometimes, not always, but oftentimes, when you use a recursion formula, the sequence itself takes on this random appearance, 3 minus 2 minus 1 minus 4. The pattern is not obvious. Moving on. Allow me to introduce you to Leonardo Pisano Fibonacci. He was born in 1170, almost 1,000 years ago. And something tells me he might have been born in Italy. At any rate, Mr. Fibonacci discovered or created, depending on your perspective, a sequence called the Fibonacci sequence. And this is it. 1, 1, 2, 3, 5, 8, 13, and so on. Can you write the next 3 terms? Pause the video and think about it. Okay, let's have a look. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21, 34. 21 plus 34, 55. The Fibonacci sequence. And all of these numbers have got a name. They're called the Fibonacci numbers, because this is a very famous sequence of numbers. Here it is defined recursively, using the 2 parts as always, knocking over the first 2 dominoes because they don't have neighbors on the left. T sub 1 is 1, T sub 2 is 1, and T sub n is the previous term plus the one that came before that. Let's do an example. Express the sequences using a recursion formula. Examine the sequence. Well, the signs are alternating, and it looks like it's being multiplied by 3. 2 times 3 is 6, 6 times 3 is 18, but the sign is changing, so it's being multiplied by -3. This is actually a geometric sequence. But we can define it recursively. We could say that each term is the previous term times -3. Or we could say that for any given term, to get to the next term, multiply by -3. There's really 2 styles of doing this. So I think I've done it the second way. Yes. To get to the next term, to get to T sub n plus 1, multiply the current term by -3. But we do have to knock over the first domino, because 2 doesn't have a previous term. B. Examine the sequence. It looks like we're going up by 6, up by 6, up by 6. This is an arithmetic sequence, but we can define it recursively. In conversation, we might say that any term is the previous term plus 6. Mathematically, that translates into this. Any term is the previous term plus 6. But we do have to knock over that first term. T sub 1 is equal to 3 because it doesn't have a previous term. Finally, well, not finally, next we have this sequence. And we look at it, it says 2, up by 2, up by 3, up by 4. You see, each of these questions are puzzles unto themselves. There's no recipe, there's no set method of finding the answer. You have to look, examine, and think about. It goes up by 2, it goes up by 3, it goes up by 4. That's interesting. This is t sub 2, and it's the result of going up by 2. This is the t sub 3, and it's the result of going up by 3. So each term is the previous term plus n. And that's the answer to the puzzle. How do you puzzle it out? You just have to try. You have to think about it. You have to say to yourself this question: how do you get 11 from its neighbor? How do you get 7 from its neighbor? And so on. Let's try another one. Here's a sequence of numbers. Let's pick something in the middle, like say this 5. How do you get 5 out of these numbers? That might be hard to do. How do we get 4 from let's examine this 4 here. How do you get 4 from 9 and 5? Well, 9 subtract 5 is 4. But if it works here, it has to work everywhere. Let's try this 4. Well, 9 subtract 5 is 4. Let's try this 5. Negative 4 subtract negative 9 is 5. Let's try this negative 4. Negative 9 subtract negative 5 really means add 5. So it appears that if I pick any term at random, say this negative 9, and subtract the previous terms, negative 5 subtract 4 is negative 9. I see. So if you can put it into conversation, you can put it into math. It seems that any term, you look at the 2 terms that came before it and subtract them, and you get it. So you want this 5? Look at the terms that come before it. Negative 4 subtract negative 9. That's really negative 4 plus 9, which is this 5. And so by looking at the terms and thinking about how they're generated from their neighbors, we can come up with the recursive formula, which says that each term is the previous term, subtract the one that came before that. And if you have 2 of these, then you need to knock over the first 2 terms. I call them knocking over because it's like dominoes. Once you push them over, they push the rest of the dominoes over. So we need to say that t sub 1 is 5 and t sub 2 is 9, and then each term is the previous term, subtract the one that came before that. I hope you enjoyed it. I'm Ziggleby at B. Stunk. Thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. Check back later for updates and new videos, and I'll see you soon.